Hello everyone, my name is Sam, okay? Actually, I'm working in IT industries for the last 20, 30 years actually. And if you look at my LinkedIn profile, you will notice that A, B, C, D plus Q actually. So I'll explain A for AI, B for blockchain or Web3 actually, C for cloud and cybersecurity, and D for data. And data actually is the most important topic today actually. Plus cloud computing, actually we'll take it inside. This is the main slide, and the other slide actually is backup slide. Okay. The main topic now or this session is how to place your data to run your AI workload. So the main thing here actually is bring AI closer to your data versus upload your data actually closer to the AI mainly. Or sometimes they call it actually in an engineering way, data-centric architecture. Okay. Why is this important? Because data is everything. Okay. Let's go into detail one step at a time. Okay. This is an example already done by a major cloud provider in Europe after GDPR. Okay. So after GDPR actually regulations, most of the worldwide cloud providers actually started to build their own instance in the European region because of data privacy. Okay, so we have multiple types of cloud. We have sovereign public cloud by owned and managed by the cloud service provider, but within the European boundaries. And we have also sovereign private cloud, special instance, and we have national partner clouds. So instead of just using the term cloud, it is hybrid cloud. And by hybrid cloud mean two things actually. There is a public cloud service I can use, okay? There is a private cloud service that also I can use, and there is my on-prem cloud services that I can use as well. So cloud is not only one thing, hybrid cloud is multiple layers. Either where it is hosted, where is my data, okay? That's why actually I'm concentrating on the data, because again, data is everything, mainly. Again, here actually it is about bringing AI closer to your data, not vice versa. And this is the trick. This is the main issue. Engineers like me actually call it data-centric architecture. And edge deployment. What we mean by edge deployment? It is again, where is my data? Okay. Do I have to push my data every time to the AI cloud to use the AI capability? No. Okay. I can push edge computing devices, very small hardware capacities, okay, running not large language models, LLM, that we all use, but instead small language models. This will provide mainly three things actually: data privacy, higher performance, much lower cost. How we are going to implement this? Usually, I'll divide my data based on my requirements and the use case and where the data is residing. Okay. So again, data is a very important asset here, not the AI, by the way. My data. Okay. And the trick is bring AI closer to your data. So edge computing or small language model already deployed near to your data actually will protect your data access, data privacy, which is very important, provide much higher performance and much lower cost. So for example, and instead of having H100 or H200s, okay, which higher cost, I can implement small AI cluster with Raspberry Pis or higher server, CPU only, okay? But even as you know, even Raspberry Pi has GPU-enabled AI server now, okay? This is much lower cost, by the way, and can be deployed at the edge, distributed near to my data, okay? And will provide higher performance, lower cost, of course, and data protection. This is the three things. But the trick here, okay, to be clear, this is a little bit difficult than this because I can actually reach any cloud service provider and rent a couple of GPUs and run my workloads upload my data and using AI on the cloud. So this is straightforward, very easy to everyone. But again, can be a little bit expensive, can be a little bit slower because latency, internet latency, and it depends on the regulator for this specific industry, for this specific type of data. So data privacy rules. This approach actually needs a little bit more skills to be deployed. But again, if you go this approach and you already embed this in your initial design for how to use AI on the hybrid clouds, okay, you will gain much high performance, much lower cost, and more secure data for your critical assets. Okay. One example, for example, in a healthcare center, if you, for example, this is a use case actually we run previously, validation electronic prescriptions. Okay, this can be deployed on small hardware boxes. Okay, running offline, running small language models, and by small language model we're talking about a couple of billions, 1, 2, 3 billion, that can be deployed in a very small device without GPU requirements. Okay, and access the data actually at the edge without even transmitting this data on the network. Okay, so this is a part of data privacy. The part of performance actually, this will process data much faster because I don't need to travel actually to the cloud with hundreds of milliseconds latency because my AI is beside my data. That's why data is very important, and that's why this is called data-centric architecture, because we are bringing AI, this local validation box that running offline small language model beside my data, not vice versa actually. So I'm not moving my data to the AI, no. I'm bringing AI beside my data. Performance, much lower cost, and more data privacy. Okay, here is some critical issue. AI, okay. AI models are trained on data. Where is this data are coming from, okay? And what is the data privacy regulations that I must follow to protect my data? So let's take healthcare sector, for example, okay? Or banking sector, but let's take healthcare. We have hospitals, we have service providers, we have medical insurance providers, we have brokers, we have many players in this network, and all of them actually are sharing the same data for the patient, okay? So I need to train my AI model to use it in these use cases. Will this players actually that already working together and competing together will share the data with each other? Usually not, because everyone is having the main side of customer data, beside other dimension, insurance, biographic data, medical data, the services I already run by this hospital or this clinic, okay? They will never share this data with each other. So the challenge here actually is how to securely share this data and use it in training my AI models, okay, to get the benefits of AI and at the same time protect data privacy. So one of the solutions is federated learning. Federated learning as simple as I already distribute my AI models, okay, besides the data at each location or each node or each partner in this node, and they train the data on the models within these premises without getting the data out, and just transfer the weights of the models to central location and aggregate all the weights from different locations actually in one AI model. Okay, I did two things here actually. I already solved the problem of data privacy because the patient is the owner of his data. Okay, so no one can share his data actually with any organization without his permission or his consensus. Okay, and also the network actually is interconnected, cooperating and competing at the same time. So I solved also this, and again, I already trained my model, but okay, of course, this approach is a little bit difficult because I need to have what we call distributed AI or decentralized AI or federated learning to train multiple instances of my model on multiple instances of the data set with different features in multiple locations and then aggregate the weights in one centralized model. So I have the benefits of both worlds actually. I train locally without getting the data out. Again, bring the AI closer to the data. This is the first point, okay? Share data anonymously without exposing any sensitive details. And benefit globally, actually. The trained final model with anomalous weights can be benefit actually all the network. So this is the other hidden part of AI security. The other part also, even within each organization, and here actually we train locally, okay? However, there is some type of data cannot be exposed, like social insurance number of the patient or the name of the patient, okay? So we usually we use differential privacy when we kind of decrypt the sensitive data before sharing with the AI model and doing the training and sharing the model again. Okay, so this is other technique. Both are complementary to each other. Okay, and by the way, there is no one size fits all actually. Each type of data or each use case or each AI model or large language model or machine learning model need data protection approach different. It depends on the case. So I can actually in one project use 5 or 6. I've seen it before actually. 5 or 6 data protection techniques like federated learning or differential privacy to secure the data. To include actually the B in my profile blockchain, one of the critical issues is how to trust AI. Okay, I need to trust actually what is AI doing. I must actually understand how it reaches his prediction. So one of the things actually continuous monitoring, evaluation, and logging, compliance actually, governance, risk, and compliance for AI, ethical AI. One of the things actually is that I must always log all predictions done by AI and put it in right protected storage. Okay, blockchain or Web3 actually is one of the very visible and straightforward actually because this is a build-only database assembled. So I have a tamper-proof actually audit log for what my AI models or models actually were doing. I can audit at any time, and this is very, very important. Without this, I cannot have legal trust in my AI system. So it is multiple dimensions. This is why actually my ABCD plus Q actually is coming. Okay, where is the Q? Next slide. Okay, to summarize, okay, this does not mean that I must do this from day one because this is very, very complex and huge amount of work. Okay, what I must do initially is to put my design or architecture to scale over time. So design decisions or architecture decision, okay, must be done ahead of time to protect my system actually from failure the next year as after year after. For example, precision, scale for specific regulated tasks, and using decision of using small language models, local, of course, versus large language model. I should put this in my design from day one. I may not implement it from day one. I might implement it in second phase after a couple of months next year. But I must put it in my roadmap and my design and my architecture. And sovereignty, security first. This is a must because it is everything is about data. Okay? It is not about AI. It is about data that I use to train the AI and actually give it to AI to give me predictions. Okay? The two sides. So sovereign AI must both be in the design criteria from day one. And edge computing in context of hybrid cloud must also be in my roadmap. Okay? Quantum readiness, actually, this is what we talk in the next slide, and privacy by design. So I'm coming from engineering background, so I'm solution architect. Okay, Any architect building a design or architecture mainly get input from only two things only: requirements, system should do X, Y, Z, and constraints. Constraints actually related to performance, scalability, security, privacy. So I must consider this constraint in my design or architecture from day one, which is privacy or security by design. Okay, the fifth part is Q. Okay, who actually heard about have a background about quantum computing? Okay, okay, okay. 30%, very good. Okay, quantum computing is the next thing actually coming after AI, but will not come actually. It is already there. Okay, so duality of quantum computing actually it has two sides actually, like a sword. It has two edges. One of them is risky because the evolution of quantum computing power, okay, and the existing of new algorithms already breaks the current cryptographic securities that we are using today, okay? But they are not powerful enough currently, 2026, but this is expected within the next few years, by 2030, 2035 maximum. So it is coming. So using a new generation of cryptographic algorithms in each new system I'm building today actually will protect me a couple of years later from being very huge cost for migration my cryptographic algorithm. So this is the bad side, okay? But the positive side here actually is if I am building or architecting or designing new system today, 2026, I can easily, without additional cost, select the new category of post-quantum cryptographic algorithms and use it in my project without any additional cost to avoid costly migration after a couple of years. The good side, but this is also coming from AI. Quantum machine learning and quantum AI is one of the most actually developing research area, and it is coming actually. There is a couple of large companies actually doing R&D in this area and expected within the next couple of years to be dominant because it will be a huge difference in AI performance and prediction. So I also need to consider also in the design, okay, the hybrid. So I'll hybrid cloud and hybrid backend. We talked about hybrid cloud, public, local, private edge, okay? All right? There is another definition from quantum perspective to the hybrid, which is using with CPUs and GPUs of course, quantum processing units, QPUs. This is starting to be available now with limited access, but this is expected during the next couple of years, short term, to be a great accelerator for AI workloads. Imagine that you can train your AI model and instead of 100 billion parameters to 100 trillion parameters on the same capacity, stored in qubits instead of bits. So this is coming. But this is not futuristic, actually. This is happening as we speak. So we must consider it in our design and future roadmap. The other dimension is if I am starting my AI project today, 2026, I should consider using the new family of cryptographic algorithm that is quantum resistant. Okay, and this will will not cost me anything if I put it in my design from the start. But if I use the classical algorithm that you are using now, and we all know that it is vulnerable already, this has been proved. Okay, I'll pay very huge amount of money actually by 2030 to migrate. So if I use it now in a new project, actually there will be save me a lot of cost. What about my previous projects? Should I migrate all my previous infrastructure in one shot? Usually not, because this is a huge migration project, but I should plan my migration in a hybrid way. Start with the critical component, with the critical data, and implement what we call cryptographic agility. Cryptographic agility is the ability actually to use either classical or traditional cryptographic algorithms like RSA and elliptic curve and ES And the same way, my middleware actually can use also the post-quantum cryptographic algorithm like lattice-based and other. Okay. And this is very small migration, just adding abstraction layer to my infrastructure. So again, I don't have to do everything actually in one shot, but I must plan accordingly because we all know what is coming next month, next year, after 5 years, after 10 years. This is the last slide, which is exactly like the first slide. Okay, start immediately on whatever resources you have. Okay, but consider scalability and flexibility. The previous session, actually, you're talking about hybrid cloud and vendor lock with cloud service provider. So if I'm designing my AI infrastructure in hybrid cloud architecture or design, I can be multi-cloud, okay? And scalable, I can use multiple services from multiple public cloud providers and local cloud providers and edge cloud services using small language models. So this must be both in my design. Also, sovereign and compliant and ethical AI should also be my essential part of my roadmap. And this is, by the way, one of the major difference between AI and MVPs and pilot projects and AI in production. Okay, of course, you all know that AI is probabilistic, not deterministic. What we mean by that? The answer or the prediction I am receiving from the AI is not deterministic like classical programming, okay, or classical algorithm. It comes with a probability of being correct or being wrong. So it is probabilistic. So AI can make wrong decisions. Okay, I need actually continuously evaluate and log and monitor and correct, retrain my AI models. Okay, to correct the errors that they made. So trust and regulation by design, this is essential part. So any AI system, usually I must consider it two parts. The customer-facing parts, the AI or LLM model or small language model I'm using, okay? And the second part, we might call it monitoring and evaluation systems that are continuously evaluating the responses of my AI models and calculating the correctness of these models and putting the plan for redeployment, retraining, and redeployment. This part is, we call it ML ops or LM ops, by analogy with DevOps. So this must be day one by design. And the last step, consider quantum-ready AI.
So we've run out of time. So
Really?
yeah.
Okay,
yeah.
okay. So
Thank
I'll take
you.
the question.
So you have a
here.
question, you can talk to him at that time.
Okay.
Thank you so
everyone.
much. Thank you.
Thank you.